Welcome. This is a quick tutorial on section 12.1, which is antiderivatives. So we're going to go one step further. We've done deriving the functions. Now we're going to go ahead and find antiderivatives, which is like the inverse of the function. So before I go ahead, it's very important you write down these formulas. So when you're working out, you know exactly what these are. Again, you do have access to a note card, so you might want to write these down on the note card too. When you're taking the test, it's easy for you to look and work out the right problem. Now, let me go ahead and zoom in here. And what I want to do is, I want to go ahead and write down, I want to go ahead and write down d by dx, the derivative of x squared plus 2. Derivative of x squared minus pi. Why not? D by dx of x squared plus 1.2. Okay, now when I'm finding the derivative of this, derivative of a constant is a 0. Derivative of a constant is 0. Constant is 0. Derivative of x squared, you know what? Let me make this, no, it's fine. Derivative of x squared is 2x. Derivative of x squared is 2x. Derivative of x squared is 2x. What I'm trying to show you is, when you're finding, if I'm trying to find the antiderivative of 2x, which is actually this. But if I'm trying to find the antiderivative of this 2x, it is this. If I'm trying to find the antiderivative of this 2x, it is this. So how do I know which is what? For this only reason, when you are finding the antiderivative, which is represented as this integral, you always put a constant c. Okay? Now, while we're still there, d by dx of x power n, is n times x to the power n minus 1. Now, integral or antiderivative of x power n, remember, because you subtract here, this is the opposite. You add, because you multiply, which is the opposite, you divide, and do not forget these constants. You need to have these constants. So it's always plus c. Very, very important. Every time you're doing anti-integral, it is plus c. Now you might say, Miss, what's a simple example of derivatives and antiderivatives? Let's say it's summertime, you're riding a bike. Your derivative will give you the speed that you're riding the bike. Now, antiderivative is going to give you, let's assume you know the speed, it's going to give you the distance you traveled. If the kids are throwing a basketball, your derivative is going to give you the speed of the basketball, the velocity of the basketball, and the antiderivative is going to give you the height which the basketball was reached. So it's always the inverse. All right, now we know that. Again, make sure you go over these formulas, always plus c, plus c, plus c blindly. Okay, now, while I'm still here, I want to show you how simple it is to remember. D by dx of e power x is e power x. So the integral of e power x is e power x, again plus c. D by dx of ln x is 1 over x. So the integral of 1 over x is ln x plus c. So they're the inverse or the opposites. Inverse, I should say. Now that we know, let's go ahead and look at this function. I have 6x squared dx. What I would like to do is I'm going to go ahead and factor the 6, integral of x squared dx, which is 6, 2 plus 1, remember, 2 plus 1. Now I divide with 2 plus 1 plus c. That plus c, if you don't put a plus c, it's going to be totally wrong, because keep in mind, my integrals will have constants like here, the 2, the pi, the 1.2. Okay, and now when I simplify this, let's see what I get. I have 6x cubed over 3 plus 2. 6 and 3 cancel, 2x cubed plus c. Now you can always find the derivative and check if you're on the right track or not. Okay, and that's exactly what I have. Now let's go ahead and see, could the three graphs be antiderivatives of the same function? Let's go back and look at the same example that I did. I did d by dx of x squared plus 2, d by dx of x squared minus pi, I think, and d by dx of x squared plus 1.2. If you look closely, the derivative of all of this is 2x, 2x, and 2x. They're asking me, can the antiderivative of these functions be these graphs? Now, it might look kind of complicated, but look what's happening. I want you all to graph these and see how the graph looks. The graph would look something like this. Going up and going down, right? So technically what I'm doing is I'm shifting my graph vertically, not horizontally. So these cannot be my derivatives. My antiderivatives are something like this, right? Vertical transition. Okay, so the answer is no. Now let's go ahead and see, find the integral, indefinite integral, and they're asking us to check by differentiation. I always like to check because it's very important. Okay, first step, I'm going to distribute. I don't like to complicate things. So this is 4x minus 2x squared dx. And now I know I can separate the integral. This is integral 4x dx minus integral 2x squared dx. And I can simplify this further. What I can do is I can bring out the 4 and say x dx. I can bring out the 2 and say x squared dx, right? And once I have this, this is 4. Integral of x is x power 1. Remember, you add 1 and divide. The formula is x power n plus 1 over n plus 1. I know there's a c. We're going to add the c in the end. Minus 2. 2 plus 1 divided by 2 plus 1. And don't forget the big C. And now when I simplify this, what do I get? 4x squared over 2 minus 2x cubed over 3. Right? Yeah. Plus C. I can simplify this further to 2x squared minus 2 over 3x cubed plus c. And now what they ask me is, they say, hey, that's very good of you. You got the integral. Now go back and cross-check. They ask me to cross-check. So what I'm going to do is I'm going to find the derivative of this to see if I can get the original function. So 2 times derivative of x squared is 2x to the power 2 minus 1 minus 2 over 3. Derivative of x cubed is 3. 3 minus 1 is 2. Derivative of a constant is 0. So boom, boom, cancel. I have 4x minus 2x squared. And that is the function that I started with. There you go. Fair enough? All right. Now let's go ahead. And again, if this is fast, pause, rewind, replay it as many times as you want. Now let's go ahead and take a look at the next one. For this one, I'm not going to check. I want you all to check because you know how to do differentiation by now. So this is 10z integral 10e power z. That doesn't look like a z. 10e power z plus 2 dz. Okay, very good. Sometimes students do put dx accidentally in your MyMathLab. Don't worry, if things like that happen, I can always go back and give you credit. I would always like to break this down. So this is 10 ez dz plus integral 2 dz. I want you to pay close attention here because I'm going to show you something. This one, the 10 comes out, and this is integral dz plus 2 comes out. What do I have here? What do I have here? I can say z to the power 0 dz. Now, let me go back. So this is 2 times 1. What is 1? 1 is nothing but z to the power 0. Anything to the power 0 is 1. And now look what happens. This is 10. Integral of ez is ez, e to the power z, of course, times 2. This is z power 1 over 1 dz. I don't have to put dz. Plus a constant. So my final answer is 10 ez plus 2z plus c. Now you might say, Miss, why did you do that? Go ahead, give me the derivative of d by dx of x. The derivative of x is 1, so the antiderivative of x is, the antiderivative of 1 is x. D by dz of z is 1, so the antiderivative of 1 is z. So these are some of the tricks that you have to remember. So let me just put it this way. Integral of 1 dx is x, or integral of 1 dz is z, based on what variable you're integrating or differentiating with. Now, if I go back and find the derivative, I'm going to find the derivatives in a different color. So d by dz, 10e power z plus d by dz, 2z plus derivative of a constant is going to be a 0. So this is going to be 10 ez plus 2, derivative of z is 1, derivative of a constant is 0. So you see, you went back to your function. So it's very important you cross-check so you know you're on the right track. All right, let's take a look at the next one. Here it says, find the equation of the curve that passes through this point if the slope is given by. Okay, so let's take a step back. Remember, to find the derivative, to find the slope, I find the derivative. To find the equation, I go backward, I find the antiderivative. So here, I am going to write down, I'm finding the integral, wrong pen, wrong color. I'm finding, so this is my slope. I got the slope from differentiating the equation. To get the equation, I have to find the antiderivative of 18x squared minus 10x dx. I like to split them. Integral 18x squared minus 10x. This is dx, this is dx. So 18, integral of x squared is, remember, you add 1 and divide, minus 10. This is x to the power 1. So x squared over 2. Do not forget your constant. And now 3 goes into 18 6 times. 6x cubed minus 5x squared plus c. So this is my equation. Now, what is c? How do I find c? There has to be a clue. And the clue is 2, 3 over 2. That means my x value is 2 and my y value is 30. Did I say 2, 3 over 2? Sorry, 232. The dog was barking, so it kind of, my attention got diverted. So 6, I'm plugging in the value, 2 cubed minus 5, 2 squared plus c. Remember, my goal here is to find the c. Just by giving the integral, you're not giving me the complete equation because, hey, what am I going to put the c for, right? And now, once I have that, I have 32 is equal to 6 times 8 minus 5 times 4 plus c. So 32 is equal to 28 plus c. So c is equal to 4. Once I have the c, you will take it back and plug it into the equation. So your equation y is equal to 6x cubed minus 5x squared plus 4. Your final equation. Remember, to find the derivative, to find the slope, you find the derivative. To find the equation, you go backward and find the antiderivative. And when you find the antiderivative, you always have that c hanging in there. And to find the c, you plug in the point to get the value. All right? Now let's take a look at this problem. For this problem, you know what I'm going to do. I do not like to work with the quotients like you know by now. So look what I'm going to do. I am just going to simplify this first, and then I'm going to plug in the integral. So x power 4 e power x minus 4x cubed. I'm going to divide each term with x power 4. Please be patient, just 1 second and you'll see why. X power 4 cancel. This becomes e power x minus x cubed x4 cancel. This becomes 4 over x. So I can rewrite this as e power x minus 4 times 1 over x. And now I simplified this whole thing. So now I'm going to go ahead and find the integral of e power x minus 4 times 1 over x dx. As you know, I like to split them up. Integral e power x dx minus 4 integral 1 over x dx. Do you have the formula sheet handy dandy next to you? If you do, you know the integral of e power x is e power x minus 4. Again, quickly. D by dx of ln x is 1 over x. So the antiderivative, the antiderivative of ln x, the antiderivative of 1 over x is ln x. So the antiderivative of this is simply ln x, and never forget your c. And that is your final answer. And you can always go back and cross-check, and there you have it. Yeah, this has to be the absolute value, of course. And you can find all of this from your formula right here. There you go. Hope this helps.